Today we're talking about conditional expressions in programming. So conditionals are used to change the flow of the program, essentially. So typically when we write a program, we just start at the top and we just put instruction after instruction after instruction. And without this sort of logic, the program is just going to execute in that order, one statement after the next, after the next, after the next. What we're going to do today is talk about how we can change that flow and why we might want to. So this is going to be things like if statements, which is if this condition, do this thing. And you can also add if it's not that condition, do this other thing. So an if-else statement. We're going to talk about some boolean logic. So the way an if statement works, you evaluate a condition and you can do all sorts of different things in that condition. It might be you just have if this one thing is true, or you might compare two things, or you might say if all three of these things are true, or if these two are true and this one's false, or if this one's true or this one is true, all sorts of stuff. Then we're going to talk about while loops, do while loops and for loops. So loops are just basically ways of executing the same code multiple times, hopefully with some differences in each loop. And then we're also going to talk about iterators, which is sort of a way of saying for each thing in this set, do this thing. It's another kind of loop, but a little bit easier way of using loops. Okay, so let's say we are writing a program for some company, and that company gives employees certain privileges, like access to special company data. And this is pretty common in either companies or just anywhere. You have to be authorized in order to do something. So we need to check if the person using the program is an employee. And if they are, you give them privileges. Otherwise, you don't. Very, very simple. Okay, so we've already covered structs and data structures and variables in an earlier lesson. So here's a simple struct to represent a person. We've got a name and whether they are an employee. Now, do we give them permissions? Well, we create a new person. We say person equals new person. We give them the name Bob Smith, and we say is employee is true. So then we're going to have an if statement. If this person is an employee, then we give them the permissions. We call give permission person, which this is a function. So here, if we were to evaluate this code, we would say if person.isEmployee. Well, in this case, we've given that value, the value of true. So this is if true, which means we're going to evaluate this. If this person was not an employee, then the code would just jump right down to the end of this block and keep going. So if statements, at least in C and C-like languages, you're going to use curly braces and offset just to give the reader some indication that, hey, this is part of the same block. And then you put whatever code you want up until the next curly brace that matches this one. And then all of that code will only be evaluated if this condition evaluates to true. So in this case, because it is true, it evaluates to true. Now we've talked about what memory looks like and how code maps to memory in the previous video. So in this case, what the compiler is going to do, it's going to take this code and it's basically going to do this. So it's going to load the person, and so it's going to evaluate each of these things. I just didn't write that here just for brevity. Then it's going to say, if person is employee, it's going to jump down to this function call, wherever this is. So in this case, we're assuming it's written at 1036. This is going to be the instructions to give the employee that code. And then what it'll do, the next entry, once this is all done, it's going to do another go to and come right back to the next entry, so 1008. So as I said in the intro, we can have if else. So if the condition is true, do this code. If this condition is not true, then it's going to do else. So this is code that only executes if the condition is false. So you can see if condition, so if person.isEmployee, do this code, and then come down to this brace. And then if this was true, it'll execute the code in this block and then jump all the way down here to do more code. On the other hand, if this condition was false, then it's going to jump down to this else statement, and it's going to look and see, okay, well, there's this code that I'm going to evaluate. So it's going to do this code. Then once it hits this brace, then it just keeps on doing this more code. So here's what that kind of looks like in memory, what the compiler is going to push into memory. So if the condition is not true, go to 1048. So 1048, this is our instructions if the condition is false. If the condition is true, then it's not going to do this go to. It's going to do, here are the instructions if the condition is true. It's going to go all this. Then at the very end of this if statement, it's going to say go to 1072, which is skipping over the else block. So once again, just to make sure this is clear, here's a condition. It evaluates either to true or false. If it evaluates to true, this code is evaluated, which is here. This code is evaluated, and then the else block is skipped and more code is executed. So these instructions are evaluated if the condition is true. We skip the else block and come down here. On the other hand, if the condition is false, so if not this condition, so not true is false, not false is true, and the exclamation point represents not. So the exclamation point represents not. So it's going to say not true, so not condition, which means false, go to 1048. So it's going to come down here. But if it is true, we evaluate these instructions here, skip the else block, come down here. If the condition is false, so if not condition, if not true, go to 1048. This block is going to be executed, which means if not this condition, come down here to the else block, execute this code. And then at the end, we don't need another go to here because the next instruction as this is done is just the rest of the code. So it just sort of executes this code, comes to this bracket. There's no other else. There's nothing else to do for this whole structure. So it just goes right on to the next instruction. So this just goes right on to the next instruction. So that's how if and if else work. Now, you can also have else if, and it'll do kind of the same thing. So it'll say, if this condition, jump to the next else, and then it'll evaluate the next condition. And if that's false, it'll jump to the next one. And when any one of those evaluates to true, it'll do that code block and jump all the way down. And if none of them evaluate to true, it'll go to the final else, if there is one, and execute that. If there's no final else, it'll just jump right to the end and just do the rest of the code. So Boolean logic is what we use to say, to evaluate the condition. So often we might just have if this variable, and the variable either has a value of true or false. But a lot of times we'll do more complicated things, like if x is greater than y, or if a is equal to b. And so that is comparisons. Then we also have Boolean logic in the sense of if a and b, or if a or b, or not a, like I was saying before. So here are some just basic tables that show how these things are evaluated. So an and is a strict A and B must both be true. So if A and B are true, A and B evaluates to true. In any other case, it's true and false. So if you imagine asking a little kid two questions, did you do this and did you do this? Did you wash your hands and brush your teeth? And they say yes, but they didn't brush their teeth, they only washed their hands, well, then they're not telling you the truth. If they brushed their teeth but didn't wash their hands, it's also false. And if they didn't do either one, it's definitely false. So true and true is true, true and false is false, false and true is false, and false is false. Now A or B, only one of A or B needs to be true in order for this statement to evaluate to true. So this would be like asking a kid, do you want candy or ice cream? And they might say yes. And so then it's like, well, which one do you want? And you have to clarify. And it might be the case, well, I want candy, or I want ice cream, or I want both. So true or true is true. True or false is true. False or true is true. And false or false is false. That's the only case. Now, if you're thinking, well, what about if I want something that's only true if one of these two things is true? That's called an exclusive or XOR. So that would be A XOR B. And that would only evaluate to true in these two cases where it's true XOR false or false XOR true. Those would evaluate to true. True XOR true, it sort of negates, and it's like, well, no, only one of these things can be true in order to evaluate to true, so that would be false. But that's only XOR. OR is very permissive, and it's just if any or all of these things are true, or in any combination, if at least one of these things is true, then the whole thing is true. And not, again, is pretty simple. If you have true things, so not A or not true, well, that's false, and not false is true. Now, we've already talked about A and B. If you start getting more complicated and saying, like, well, let's put the outside if not A and B. So not A and B. So A and B is over here. We've already talked about this. What about the not of that? So basically not right here. So false, true, 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 because not true is false, not false is true, not false is true, not false is true. So that's exactly what this is. Not A and B. False, true, true, true. And the way this works, it's sort of like distributing a negative if you have like negative parenthesis A plus B. If you were to write that out a different way, it would be negative A minus B. So it gets distributed to each thing, which means in order to get to the same truth table, we have to do not A or not B. So this is the exact same thing. So we can run through this and say, well, if this is true, then we do a not, and that becomes false. Not true, that becomes false. And then false or false is false, which is the case down here. So just keep in mind, if you're going to distribute a not, it's going to do a not of each variable, and it's going to do a not of the conjunction, the joiner. So and flips to or, and then if we look at A or B and then not it, the same thing happens. So A or B we already talked about. Now let's say not A or B. Well, not true is false, not true is false, not true is false, and not false is true. So that's exactly what we have right here. True, true, and then that's A or B is true, and then we do a not of that, and that becomes false. And same thing here, true or false, that's true, then we not it, and it becomes false. False or true, that's true, not it, that becomes false. False or false, that's false, not it becomes true. And again, if we distribute the not, it would be not A, and then the or flips to and. Not A and not B. true, true, false, true, false, 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 true, false, 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 true. You may want to give yourself some exercises and write these things down without referring to these tables and see if you can figure this out yourself and make it complicated and just kind of work through it. It's a good way to learn the Boolean logic. Okay, back to about giving permissions. So we might have different levels of permissions. So we might have standard employee permissions, and we might have administrator positions for like IT specialists. So maybe Bob Smith is our IT professional, and we only want to give Bob Smith special admin position or permissions. So to change the code a little bit from our earlier example, we could say if person is employee, so that'll evaluate to true in this case. Then we're going to do an additional check. If person is equal to, if person.name equals Bob Smith, then we're going to give it admin permissions. Otherwise, we're just going to give them standard employee permissions. And if they're not even an employee at all, we're just not going to do anything. We're going to do something else as far as permissions. So the whole purpose of this series is to try and get you up to speed on just some basics of programming so that we can start working on some game programming. So where are some places that these if statements might come up in a game? Well, you might check, is this thing that I'm interested in, say the player, is the player grounded, meaning on the ground? If so, or if not, if they are not on the ground, then I'm going to add gravity to their velocity. In other words, if they're not on the ground, then gravity is going to affect them and start pulling them back down towards the ground. Otherwise, so not grounded, which means if not is grounded, and then we do this else if, so if they are grounded, then we're going to do this, and we're doing an additional check. Did we get some jump action? So input is action pressed jump, which just basically is saying, did the player press the jump button? Well, in that case, rather than adding gravity, we're going to subtract a jump velocity from their velocity, which means they're going to get an impulse of immediate velocity upwards, which means that's how you jump. Now, you might say, well, what about they have to be on the ground? Well, we've already checked that. If not is grounded. So if they are not on the ground, this code executes. Else if, well, this only executes in the case they are, in fact, on the ground. If they weren't on the ground, this would have executed and it would have jumped down. But in this case, we've already checked, are they on the ground? So now we can check, did the player press the jump button? And you might say, well, what about if the player pressed the jump button up here? This is going to be skipped if they're not on the ground. So if they're not on the ground and the player presses the jump button, well, you can't jump when you're not on the ground. And we're not taking account of double jumps or other types of jumps in this case. We're saying strictly you have to be on the ground in order to jump. So if not on the ground, apply gravity. Otherwise, if you are on the ground and the player pressed the is action pressed, or the player pressed the jump button, then we give the player jump velocity. Now here's another example. In this case, this function get axis, it just returns a value between, say, -1 and 1, and it depends on if the player's using the joystick. So if they're fully pressing the joystick to the left, it'll be -1. If they fully press it to the right, it'll be +1. And if they're not pressing the joystick at all, the direction will come back 0. So if direction is not equal to 0, meaning it's either less than 0 or greater than 0, then we add some direction. The direction, which is this value, times speed is their x velocity, so their horizontal velocity. Otherwise, we're going to do this move toward, and basically what this does is it linearly reduces their velocity to 0. So it's like applying friction. So at some point, friction's just going to stop them, but they're not going to stop on a dime. They're going to kind of slow down, and then eventually they will hit 0. So that's it for if conditionals. Now we're going to talk about loops. So the most basic loop is the while loop. So loops basically are just a way of executing the same code repeatedly, but we need to have something changing. Otherwise, it's just while true, which would mean it would just run forever. And that's not good for a program. Even for a program like an operating system or a game, because we want to eventually be able to turn the thing off. So it would be like, while the player has not left the game or exited the game, keep doing the game. But once the player says quit the game and stop running. So in this, see if you can kind of figure out in your head what you think this code would do. So we've got while x is less than 10 and x we initialize to 0. While x is less than 10, print x, and then x equals x plus 1. So if you think about this, what is this going to do? This is sort of like an if here, and then like a go back up to the top, and then reevaluate this condition after the code has run. So I've laid that out over here. This is kind of what the memory would look like. At first, we initialize the value x to 0. Then if x is greater than or equal to 10, we skip the loop. We go down here to more code. So go to 1020, here's 1020, and we just completely skip the loop. Otherwise, if x is less than 10, well, then we print x, and x equals x plus 1. So if it starts at 0, we're going to print 0, then 0 equals, or x equals 0 plus 1, so x becomes 1. Then it's going to go back to the top of the loop. So just like here, it goes back to the top. It checks the condition again. If x is less than 10, well, right now it's 1, so we print 1, x equals 1 plus 2. Come back here, check the condition again. 2 is less than 10, so we're going to print 2, x equals 2 plus 1 is 3. It's going to keep doing this up until when x becomes 9. So 9 is less than 10. Then we print 9, x equals 9 plus 1, that's 10, and then it comes back up. So again, over here, x equals 9 plus 1, that means 10. Then up here, it's going to say if x is greater than or equal to 10. So 9 plus 1 was 10, so x is now equal to 10. So if 10 is equal to 10, go to 1020. So we jump down here to 1020 and we skip the loop. Same thing over here. After when x was equal to 9, we do x equals 9 plus 1, that's 10. Come back up to the top of the loop. 10 is not less than 10, so we jump down and skip the loop. So we come down to the last curly brace or the closing curly brace, and then we just do whatever code is next. So that's how while loops work. So again, we want to make sure that we are executing the same code repeatedly on different values. Something needs to be changing, and that thing that is changing or has the capability to change, that's what we're putting in our condition. So if we do this as opposed to this code, see if you can see what's different here. X equals 0. While x is less than 10, print x. Well, as this says, this is going to print 0 forever. C and other languages like it, it'll compile this code just fine. It'll create these instructions, and it'll just look like this without this x equals x plus 1. Then it'll go back up here. Well, x is still 0. 0 is not greater than or equal to 10. So it's going to print this instruction's not there, so it's going to come down, go back up, and this code is just going to run forever and ever and ever and ever. So you as the programmer need to make sure that you are checking these things, and if you run it and it's just running and running and running and not doing it, like not quitting when you're expecting, these are the kind of things you need to check for. Oh yeah, I need to make sure that I update the value of x at some point. And also, things can happen where even if the thing is changing, it might be changing in the wrong direction. So this is sort of the same problem where x is 0, and then we say while x is less than 10, print x, but then we inadvertently wrote x equals x minus 1. So in some languages, this will just run forever. In C, it might just run until there's wraparound and it goes from negative to a positive value, but that's going to take a really long time. If we're only expecting to print 10 values and all of a sudden we're printing, negative 30,000, that's a pretty clear error. Oh, I messed something up in my while loop. So that's something to check. But otherwise, this is sort of the same problem as the while true, because effectively, if you have a value and you're checking whether it's less than 10 and then you're decreasing the value, it's just going to run forever. So be careful of that. A do-while loop is another construct. Not every language is going to offer this, but effectively what it is it moves the location of the condition. So it says, do this code, and then at the end, it has the condition, while x is less than 10. Now, in effect, this is exactly the same as the while x is less than 10 loop that we had earlier. But this one, it'll always do the instructions in the loop at least once. So you can see that over here, how that gets translated by the compiler. It's going to set x equal to 10, then right away, no check of the conditional, it's going to do the inside of the loop. Print x equals x plus 1, and then if x is less than 10, go back to the top of the loop, go to 1004. So then it's going to increment, it's going to come down here, and then it's going to go right back up. So let's compare that to what we had before. In the while loop, we check the condition first, and only if the condition is true, then we do the inside of the loop. In the do while loop, we always do the inside of the loop at least once, and then we check. So there are times when that might be what you want. You want to always do it at least once. And so in that case, you can use a do while loop in this way. To make sure you always do the internals at least once. Now a for loop is, at least the C style, C, C++, Java, all these other C style languages, it's a shorthand for the while with one other part. So in a standard while loop, we have a declaration for the iterator, so int x equals 0. So now this x is in scope for the remainder of whatever code block includes all of this. So we do the int x equals 0. So now we've allocated x. Then we do all this stuff with x. And then outside of the loop, x is still in scope. So you could change the value of x. You could refer to the value of x. You could write it. You could read it. X is going to be in scope forever. And that may not be what we want. And also, this is kind of tedious to write out every time we want to loop. And, like these sorts of errors, like here and here, where we aren't changing the value of x, it often is the case that the value of x is being changed at the very bottom of the loop. And this might be a lot of code. So you might just assume, oh yeah, I changed the value of x, of course I did. And then you run it and then it doesn't quit and it just runs forever. And then you're like, what is going on? Well, the for loop, it changes things so that the entire set of state being used inside the loop is in one line. So in this case, we do for, and then we do our initialization, int x equals 0, semicolon, x less than 10, semicolon, x equals x plus 1. Now, hopefully you can already see how these two things map to each other. So we've got initialization, condition, iteration. So in this case, we're going to come in, going to hit the for loop. We initialize x, Then we do print x, come down here. Okay, that tells me to go back to the top of the loop. And the way it goes is, so instruction comes down, we do the initialization, we print, we go to the bottom curly brace. That tells us to go back to the top. So the way it goes is it comes way out here, goes to the far right side, does x equals x plus 1, it bounces over here, check is x less than 10. So if we have 0, come down here, x equals 0 plus 1, now it's 1. 1 is less than 10, so we're going to print 1. And then this just keeps happening until x is greater than or equal to 10, at which point it's going to come down here, iterate, go to 10. So 10 is not less than 10, so it comes down here, x goes out of scope, and then we have more code. So at this point, after we've passed the for loop, we can't refer to x anymore. X is just out of scope, it's out of memory, we're not going to be able to use x anymore. Now that might be good if we want to have another for loop down here to do something else, and we're also going to use x as our iterator in that other loop. Whereas for this one, we would have to reinitialize x and say x equals 0 again, and we'd have to remember that. So again, the structure of a for loop is like this. For, initialization, do the loop code. Well, actually, it'll do the initialization. It'll check the conditional. Then it'll do the loop code, come back up, iterate, check the condition. If it's true, loop, come down, iterate, check the condition, do the loop code. And then once the condition is false, then it'll quit and it'll do the rest of the code down here. So one more time to try and map it into what it looks like in memory. We've got for, initialization, condition, iteration, loop code, A, B, C, D. In memory, what that's going to look like, the first line, it's going to do the initialization. If B is not true, then just jump outside of the loop, so down here at 1040. Otherwise, it's going to do the loop code, do the iteration, and then go back up to the loop. So then, so this iteration is right here. It's going to iterate, jump back to the top of the loop, check if the condition is true, and if it's not, it'll exit the loop, come down here. Now, of course, I left a lot of stuff out, like the variable going out of scope and all that kind of stuff, but this is just the general idea. So one more thing. This is in the scope of computer science, more relatively modern, and that's the idea of iterators. And so more modern languages have this notion of iterators, which are an improvement over for loops, or can be used in for loops, but in a different way than what this looks like. So let's say we have this array, and we declare it to have 10 values. So then we set up a for loop, and we say, okay, so I've got 10 values in my array. I'm going to start at 0 because the array starts at 0. So I'm going to say int x equals 0, while x is less than or equal to 10. Keep doing this, and then set x equals x plus 1. This is just shorthand for that. Print int array x. Now, what's the problem? Well, the problem is we said x is less than or equal to 10, which actually is the 11th entry in this array. But this array only has 10 entries, not 11. So if you think about it, 0, 1, 2, 3, 4, that's the first 5. 6, 7, 8, 9, or 5, 6, 7, 8, 9 is the next 5. 10 is the 11th element. But that element is outside of this array. And if you're using a language like C, which is not a memory safe language, you're going to be accessing memory outside of what you've actually allocated. You're going to be looking at someone else's data, which you probably don't want, or if you're malicious, you might want that. And so the language isn't going to stop you from doing that. So we want to make sure that we prevent that. Now, an iterator works differently than this. An iterator basically says, all right, I have this thing with 10 elements. The compiler itself knows this thing only has 10 elements. So you just say for element in this array, print the element. And notice we don't have to do any conditional checks. We don't have to do any initialization other than this for element thing. And we don't have to do any iteration. All of that is taken care of in the language itself. Now, this is not a feature in C, but in many other languages, it is now a feature. Languages like Python, C++ has this now. It didn't always, but it does now. And all sorts of other modern languages like Zig and Rust and all sorts of things. So this is a really nice pattern. So while this pattern is nice if you need to use it, this pattern is much safer. It's much better. You should really prefer to use iterators over something like a standard for loop with where you might run into this out of bounds, off by one error. So where might we do this in a game? Again, this series is about getting you up to speed on what we might do in game programming. So maybe we have this visible entries data structure, and that gets the visible enemies. Now we might do for enemy and then semicolon. That means this is one element of this collection. So for each element in this collection, for enemy and visible enemies, maybe we have this user interface function that is set to draw a box around the enemy. So you've got a bunch of enemies on the screen, and you have like some UI like in a flight simulator or maybe some kind of mech game. It's going to draw a box around each of the visible enemies so you can clearly see them, so you know who the targets are. So rather than having to iterate through each one individually and checking the length of this thing and making sure that you're not exceeding the length, all of that will be taken care of by the language, and you can just call it this way and make your life very simple. So to wrap up, there are various types of conditionals. If, which can include else if and else. There's loops like while, do while, for, and iterators. And then all of these things operate on conditional expressions, which use things like boolean logic, comparisons, and or not. So I hope this is helpful, and I'll see you in the next one.